We are about to start, and just maybe a few seconds more for other developers to join us today. And happy to see you again. This is the final in this year online roundtable for developers that we do. And we have two amazing sessions today, one from Benjamin and one from Thomas. And let me see, I think I will just stop sharing because there's basically just one slide. And I cannot see you all when I'm sharing. So I do prefer to see you guys. All right. Nice. So I think, so the general agenda is that we have two 15 minutes presentations and Q&A, and then we can go back to discussions, to introductions, to exchange what you guys want to share, and maybe what you want to ask to our experts, Benjamin and Tom here today, okay? Yeah, Benjamin, I'm just passing the floor to you.
All right.
If
thanks,
you're
Olga.
ready.
Yeah, let me just share whatever full screen. So I wanted to talk a little more about foreign tables, something that we've added as an experimental feature in 23.1. It's still experimental, meaning that we still have more things that we really want to do, but we also are very curious about how you would like to use it. So we think this is a great topic for a roundtable, and definitely please do ask questions or do share your candid comments about, well, whatever you're seeing. So anyway, I got a couple of things to get us started. Then we'll do a bit of a demo, and then I have some questions for you for having a conversation about. And then after this, my colleague Tom Dyar will also be presenting another bit of technology that I hope you find exciting. All right, so foreign tables. So what are foreign tables for those of you who've never heard about it? So the idea is to be able to project external data, foreign data, into InterSystems IRIS SQL, such that it can be used as if it were a regular IRIS SQL table. So it's a fully standard part of or it's a part of the IRIS, the ANSI SQL standard. So there is no funny syntax that we invented. So if you think the syntax looks weird, that's not on us. It really is meant to be standard and interchangeable with what you might be familiar with from Postgres or whatever. Right now, we support JDBC and CSV sources. We're very close to also finishing up ODBC support, and then we'll be looking into support for Parquet sources as well. And if you have other suggestions, we'd be all ears and want to know what you think. So you may already be familiar with the load data command. So the idea of foreign tables is to project data that is not managed in IRIS to IRIS SQL, such that you can just query it and include it in SQL tables. But it's kind of a read-only projection. Load data, which already existed just a little longer, is a tool for loading data into IRIS SQL. And when we refine the syntax and the options and whatnot, we obviously are striving to make sure that everything that we support in load data is also part of what we support in foreign tables, and the other way around. That sounds straightforward, but well, if one of them is part of the SQL standard and the other isn't, then that means that, well, there was some work for us to do there, and we're still kind of getting both to the exact same level. But especially when we're talking about the more subtle options and refinements, then they're really getting in good shape. All right, and so I mentioned we're projecting data from an external source rather than ingesting it, which is what load data does. But when we're projecting data from an external source, if that external source is a database itself, we'll try and figure out if there's any work that we can delegate to the remote database, because that means less work for IRIS, but most importantly, that might save us time, because if we can apply a filter in the remote database, there's less data to send over the network. So all good news. So that's what's called predicate pushdown. So a where predicate and where clause that applies or that can be resolved entirely by the remote table will push that down. If we want to get a little more into the marketing theories, you've definitely heard us talk about data fabrics and smart data fabrics. If you've followed any of our presentations or summits over the last year and a half, 2 years. So the idea of a data fabric is to make data available to end users, data consumers, data analysts, data scientists, application developers on their terms. So without those users, those consumers having to worry about how the data is physically persisted or if it is physically persisted anywhere at all. So as you can imagine, foreign tables is an important ingredient to it because it's all about projecting data into IRIS SQL so that consumers of IRIS SQL can see it, regardless of whether it is local to IRIS or whether it is some file sitting on an S3 bucket or some remote database that is part of the broader fabric. All right, with that background, I wanted to also point out that we have a nice video on this subject. So if you just go to learning.intersystems.com, you can find this one, or if when we send out the slides, we'll also include that link. So how does it really work? How does it look if you want to start working? So there's actually two concepts, or three concepts, if you will. So foreign servers are sort of representing a source, a data source somewhere else from which you want to project data. And then these servers have a type. They can be a database, they can be a file system, and that type is sort of represented by a foreign data wrapper. The foreign data wrapper is sort of the type is sort of the code, the adapter, if you will, that helps us retrieve data from that source. So in this case, we're talking about a server that has a name and that is of type JDBC. And then here, the connection clause is just how we capture the credentials. So right now, we're using the credentials from SQL gateways, which you may be familiar with from other parts of our platform. We are working on a sort of a native wallet type of functionality, which will offer a means for secure storing of credentials, and as soon as that's available, we'll make sure that that can be directly invoked from SQL commands. So I forgot to mention that early on. This is really a pure SQL feature. So the idea is that you can start playing with it without having to get into ObjectScript or embedded Python for any of the work. So once we have our server defined, we can create one or more tables that project data from that source. And the easiest way to do this is to create a foreign table, just point out the server and point out the table name. That table name is between quotes, and actually that shouldn't have that trailing dot. But that table name is in parentheses because there may be some sort of a difference in how the remote database handles delimited identifiers or whatnot. So that's why this one is actually passed in as a literal. But if we're pointing to a table, we can just infer the metadata from that table and create the table with the exact same columns as it has in the remote database. If we want to override it, we can do so by specifying a column list as in a regular create table statement, and then we just need to provide, well, the columns that we want to project inside IRIS, and then in the values clause, how that maps to the source table. So what you see here in the values clause is how it looks on the source, in the source table, and how it looks in this column list is how you want it to look on the IRIS side. One more example for files. So for files, I mentioned we support TSV, so that's the foreign data wrapper we'll use here. And then the host, this is a standard keyword for the create foreign server command in the ANSI SQL standard. It's just a path to a local server, and then you can do what we did in the second example on the previous slide. So we point to the server, we tell it which file to open, and then in the using clause, which is fully aligned with load data, we can specify the additional parameters. This looks a little verbose because, well, from file, well, I already told it that this was a foreign server that's based on files, but that's just to make sure that it's using the exact same syntax as load data so that you can easily exchange or switch between the two in your scripts. All right. So I mentioned that we first released this with 23.1. Between then and 23.3, we added a couple of new small-ish things. Well, small, but apart from some bug fixes based on early adopters. We added catalog views for it. We significantly improved how it's represented in the query plans. I'll show that in a minute. And then we added more support for predicate pushdown. That's actually a theme that will come back in the future as well. So support for ODBC sources, maybe 24.1, likely 24.2. A little more refinement in how you need, in what privileges you need in order to create a foreign server so that you can have select procedures or select privileges on a foreign server required before you're allowed to create foreign tables against it. So that's something that for which the design is ready and it's waiting for implementation. And then some other work that's sort of trying to keep abreast with what's happening on the load data commands, so including support for small expressions. So say you have a file where you're having a date column and the date is not expressed in an ODBC format, but in something that is slightly different, or maybe some local format, then you can take care of that in a values clause in the very near future. All right, with that, let's any questions so far before I switch to a little bit of a demo? Okay, I'll just move ahead and you just give a shout if there's anything you wanna ask. So I'm starting from a blank or more or less blank database. So what we'll be doing here is we'll be creating a foreign server with a particular name that's mapping to files in our data directory. So I create the foreign server, and then now I want to map a file that is stored in this directory to our as a foreign table. So let me show you how that table looks, how that file looks. So this is the file, just as a simple header, and then a date field, nicely in ODBC format, and then a bunch of columns with numeric data. So the rest of this repository has much more, but Tom will also be talking more about that shortly, so I won't spill the beans on it. So if we looked at that header and how that structure looks, so we've got our timestamp column and then a couple of numerics. So I point it to my new server, I tell it the file name, and all I needed to do was tell it that there was a header. So that's all we have to do. And now we have a table that we can simply select from. So now the data that we're going to see here is not stored in IRIS. It's just passed through. It just projected from the file into IRIS, and I can just query it and use it in joins, use it in whatever I want, and then the foreign table infrastructure will read it from that file on the fly. So this is great for if you have really big files sitting somewhere and you don't want to waste storage by importing them in full, or if it's fast-moving data that's sitting somewhere else and you don't want to need to synchronize it with the external data the whole time. So those are typical use cases for foreign tables. Okay, let's do something slightly fancier and create a foreign server for a Postgres database. So here I have my Postgres database. If you don't know what Postgres is, great. That means that you're a very loyal IRIS customer. But Postgres is of course a nice, a very solid open source database platform as well. And I have a a simple table in here with some basic data. So now I'm using dbeaver to just query or to just look at that directly in Postgres. But say I'm in this this data fabric scenario where I want IRIS to be the launch pad to get to all of the data. So in this case, I can create a foreign server that represents my Postgres database. I already stored credentials in a SQL gateway connection. And now I can create a foreign table that just represents this table, the remote table, which is in the public package. And now I'm creating it in the PG package. And I can see all of that data. And now, so I mentioned predicate pushdown. So what is predicate pushdown? Predicate pushdown is the ability to push down query predicates to the remote server. So how does that look? Well, you can see it from the query plan. And to get the query plan, you want to use. So this is, as I'm sure you know, the explain output is not always as easy to see if you don't use the management portal. But anyway, so here we go. So here in the query plan, you can see what it's doing. So I'm reading from my local foreign tables pg.product, and it knows that it's a foreign table. So here you can see what the exact query is that we'll be sending to our remote server. And this is the nice piece that I wanted to show. Well, it's not rocket science, but it also works for much more complicated queries. So we identified that our query predicate on price is can be fully resolved by the foreign server. So we're adding that to the remote to the query that's being sent out, and then we no longer need to resolve this or check on that condition on the IRIS side. All right, so that's what we have in the product in InterSystems IRIS 23.3 right now. So I also wanted to show you two things. Well, one thing that I didn't really. I can. Can I? Yes, I can. I can show you something from my cheat sheet. So you may think like, well, this is nice being able to project from a file, but I don't want to type as much. So can you help us with that? Yes, we can. So for those of you that might have seen that we have a utility library, which I, in a sort of a very vanity way, named bdb.sql, but that's because of naming conventions and whatnot on the developer community. So I have a create foreign tables procedure that I can just point at this this whole folder, and then I'll tell it to, well, before both. I'm going to not do that because I'm on JDBC, and then I want to have this all in my demo 234 schema. So if I run this now, let me make sure to add a semicolon. And then if I go back to my refresh. So now it created tables for each of the files in my folder. So if you want to save yourself the effort of typing, this is a simple utility that just reads the first 100 lines and then tries to guess what the actual data types are. So if you want to look at what this one looks like, so it correctly inferred timestamp, numeric, integer field types. And then the second little thing in our utility library is something that one of our customers that's using foreign tables has asked for. So their use case, they look at IRIS really as sort of the beachhead into their entire data ecosystem. So they're fully bought into the idea of foreign servers and foreign tables, but they also want to be able to, if you want to create a foreign table on an existing table, that's fine if you know what the table looks like, or if you know the table name. But they also wanted to have the freedom to send a query directly to a foreign server and get the query results back. Now, if you're familiar with SQL, that is not trivial, because in SQL, typically, or kind of semantically, when you prepare a query, you should know what the result is like, or what the result set structure is going to be like. And that's sort of, again, that goes against the fact that we're passing our query in as a free string, free text string. And the reason why we need to do this is that this may be Postgres syntax, or this may be Oracle syntax. So I really can't support Oracle syntax inside IRIS. So, but anyway, with this utility, we're making use of a facility and stored procedures that support multiple result sets, and it works. So now we can just send a random query to a random foreign server, and this is giving our customer the flexibility that they were looking for in order to use foreign tables really as sort of the starting point of their data fabric architecture. All right, I've been talking for way too much. So I had a couple of questions for you.
Benjamin, we have a question in the chat.
Yeah, I saw it. Scott asked whether executing the query, does it build it in IRIS versus on the foreign server?
What I mean by that is, like, we have some high volume interfaces, and when I tried to execute the query through JDBC, the throughput was very bad. So I ended up having to go to using stored procedures to give me the return that I needed, because it would, you would build the SQL, you send it across the JDBC, it has to build it on the server and then execute it. So when you use foreign tables, does it just automatically execute it within IRIS and doesn't have to do that extra jump to build it on the foreign server?
So it will, to the remote database,
yeah,
IRIS will appear as a JDBC client. So
okay,
it will run through the result set. It does not necessarily materialize the whole result set on IRIS. So it kind of scrolls through it a little bit.
okay,
But it depends a little bit on what you're doing on the IRIS side. So if your query is really something that we can entirely pass through and we don't need to do anything anymore on the IRIS side, then you're good, and we'll just pass through the results. If you're joining it with something that's on the IRIS side, then of course we will need to do some more. We will need to materialize a little more on the IRIS side. But this is sort of an active area of research. We're looking for more types of predicates that we can push down to the remote server, or other ways how we can be more efficient about it. But if you have tried something in particular and you didn't like the throughput, please let us know, and that might give us the inspiration that we're looking for here.
Yeah, I haven't been able to get to it yet, but yeah.
Okay.
Yeah.
All right.
To ask some questions. So I didn't hear that. So foreign table are read only, so it's just only for select. Yes.
Yes. Right now, that's what foreign tables do.
Okay, I see. And how about some incompatibilities in data types, for instance, like JSON-B in Postgres, or time zones, which we don't have, like some features in IRIS? How it's
Yes, I mean, like older SQL still has image, where they're supposed to change it to var binary, but yeah, like SQL image too.
So right now, var binary and any stream fields in general, so including blobs and clots, are not yet supported by foreign tables. We have some work in the gateway that we plan to make that possible. So that's one data type category. Now for others, we are, at least when you're using JDBC based foreign tables, we're sort of at the mercy of what the JDBC type mappings look like. So if the JDBC type mapping looks at a timestamp with a time zone on the Java side, it appears as a regular timestamp. That's how we will pass it through. It's an interesting question if you have some concrete examples that we can look at.
Yeah, I don't have concrete examples, just experience from multi-database libraries. It happens that for the current Java contest, I found a project named Presto.
Yeah.
Yes,
I saw that. Very cool.
made library for IRIS there, and right after that, I found fork from Presto, Trino, which is much more powerful. Presto is read-only. Mostly it doesn't support insert. Kind of can, but it doesn't support directly. But Trino much more powerful. Have options also for it. And hope I will finish this project too. This works, a bit different. Yeah, it's not connecting IRIS to everything else. It's just merges everything else to something else. But the big idea is that it uses universal SQL for everything. So all databases behind, no matter Postgres, IRIS, Oracle, whatever, you will use the same syntax, Presto or Trino syntax, but behind the scene, our drivers will do all this magic to make it working on different databases. But databases, and also it's like accessible from one connectivity, the same way, kind of like foreign. It's not foreign tables. It's defined as catalogs, and everything is just accessible behind it. It looks great.
Yeah, it's good that you bring it up as an example of a data virtualization solution, because that's indeed what Presto, Trino, but also Dremio and Denodo are focused on. So those are all platforms that really that don't really store data themselves. So they're not really databases themselves, but their focus, their core business is to offer query support across multiple actual databases that sit in the background. So that's this. You could think of foreign tables as a data virtualization solution, but to be honest, that's really not how I would position it, because foreign tables is really for including remote data in your IRIS application. If you only have remote data, trying to do it all with foreign tables is probably going to is not like the perfect tool for the job. That's indeed where the Presto, Trino, Dremio stuff comes in. So this is
and one more question. Like, so foreign tables in this case, IRIS connects to other databases, but how about other side? Others connect to IRIS from other sites. Their features make IRIS data accessible.
Well, it depends on the database, though. I mean, if you look at
Postgres has this feature, so you can connect to other databases like MySQL. You can connect to IRIS at the moment,
right?
But it's I suppose it's also reasonable, like just in a sense, to make IRIS data is accessible. It's not just a place where we put everything and forget that it's only place where you have to store it. Just, yeah.
Yeah, I think I don't know what the actual.
Yeah, because I don't know if I don't know if Microsoft SQL Server can even use like JDBC connections. I know they use ODBC connections to link tables, but I'm not sure Microsoft SQL can use JDBC.
They use a slightly different model for this.
Yeah.
But in theory,
Yeah, they have wrappers, but
I'm not sure if my Postgres instance is set up for this, but it should be something like no, how is it exposed? I mapped it to 4.1.7. And now how to pass in the, well, anyway, it should be something along these lines. Let's see what kind of an error that Postgres told us. No. Okay, I'd have to look it up, but so this is sort of the what you described the other way around, going from Postgres into IRIS should look a little bit like this. I'd have to look up the actual syntax, but that could definitely also work.
Benjamin, we have another question from Enrique in the chat. If you could have a look.
What's the use case of for perfect. Yes, indeed. So I was getting ready to call that out. Thanks for bringing it up, Enrico. So the foreign tables, it's not like a novel concept. It's part of the ANSI SQL standard. And also for those of you who've been working with IRIS, and Enrico is one of those. So we already had linked tables. We already had a JDBC gateway. And specifically JDBC outbound adapters in our interop solution. So why did we reinvent the wheel? And I should have stepped that up front, but I was going to get to it. So it's not like I wanted to hide that. So our link tables were designed 15, maybe 20 years ago, based on a JDBC gateway implementation. And then we also had link tables based on an ODBC gateway implementation, and they had different levels of integration with the SQL optimizer, such that to be honest, the code wasn't very pretty. It was a little convoluted. There were different limitations on what a link table on top of a JDBC connection could do versus what a link table based on an ODBC connection could do. So what we wanted to do with foreign tables was do it all in a much more standardized way, a pure SQL solution based on a unified gateway that is the same for JDBC and ODBC, and just take it from there. So that's sort of, so what is the, to get to your specific question, what's the use case of foreign tables compared to the JDBC gateway queries? If you're using JDBC gateway queries today and you're happy with it, don't worry. If you're not very happy with it, for example, because the performance is not all right, or if you want a little more flexibility and don't want to go through the system management portal to do each and every change to a link table that you would like to do, then you can start taking a look at foreign tables. So right now, we're not, we haven't covered every link table scenario with foreign tables, but it is our intent to do so. It is our intent to make foreign tables the successor of link tables, and avoid some of the shortcomings and limitations of link tables. So if there are, that's really what this what these last two questions are about. So if you have used link tables or used the JDBC gateway directly, if there's anything in particular that you like that we absolutely must make sure that we include in the foreign table infrastructure, we're all ears. And with that, I think I'm pretty much at my allotted time, and I'll
And we have another question. Let's do that. If you can quickly cover it, and then we'll move to a presentation made by Thomas, and then we'll hopefully have some more time to answer all the other questions.
Okay, to Ben's question. So if we need to join tables, two tables that are in two separate IRIS instances, then the answer is, as you can guess, it depends. So with foreign tables, you have you're completely abstracting away the two IRIS instances. So if say you have a server A and an IRIS server A and an IRIS server B, and tables A and B, so you can use foreign tables to project table B into server A, and then it could as well have been a file. It could as well have been a Postgres server B. So you're really abstracting things completely. So if that is something that you need for your application, the loose coupling offered by foreign tables might be exactly what you need. If you need to, if this is a big table with a complex join where you want to make sure that you leverage the smartest level of or the best caching and network use as you can, and the two servers are close by, then you could also consider using an ECP mapping to map server B's whole package into server A and do the join there. And then you don't need the loose coupling offered by foreign tables, and you can just use your query directly on ECP map table. So then the connectivity or the communication will be at the level of blocks, IRIS database blocks, rather than at the level of a JDBC connection. And Robert's question about mix of foreign tables with internal tables is absolutely possible. So you can just mix and match them. That was really the goal. So this was not the case with linked tables. With linked tables, there were limitations on joins in some cases that were hard to specify upfront. But with foreign tables, it is just like another table, and you can join them however you like.
Thank you, Benjamin.
I'm really going to shut up.
And really love this questions activity. You can, if you still have some questions, you can put them in the chat, and probably we will just be answering all together. But now let's move to the next presentation. Thomas, this is your time now.
Hello, everyone. Let me share my screen. And let's see. Well, I hope this works. Does that look right? Have something about data products up there?
Yes.
All right, great. So yeah, I just wanted to kind of talk a little bit about data products and kind of what that means. It's a term that I've seen around, so I wanted to dig in and look and see what people thought that meant, and maybe put it in my own terms. And we'll kind of look at an example of how you might build those kinds of artifacts with InterSystems IRIS and DBT. And we'll talk about what DBT is. So this is the overview. We have a little example that we'll get into using DBT, and I can show a bit of a demo. So I start out just kind of define what is a data product. It's really just a glorified data set. You might think of it as a really kind of curated data set that is that might be a reproducible, reliable representation of that crazy spreadsheet that is running the whole business, right? So you might have all that crazy stuff going on, a lot of data transformations and things that people accrete over time for business use, but that's not very sustainable and scalable. So the idea of a data product is to kind of turn that logic and turn that data into something that really provides business value and is more scalable and maintainable. So it's something that's reliable. That's kind of what a product should be, well documented, and it's data set, some kind of data asset that provides business value. So, like I mentioned, some kind of spreadsheet type of thing, or maybe in the case that we're going to look at is taking some raw data that comes from retail, like data stream, and transforming that into a kind of analytics ready representation that is cleaned up and ready to use. So you first of all have to take your raw data from multiple places, and Benjamin was talking about how foreign tables is a way that you can do that. And in our example, we start from just a single foreign table, but as you saw, you can get pretty complicated there. Turn that data into some useful information, right, by doing transformations, cleaning it up, having testing and documentation around that so that it's usable by a lot of people around the organization, auditable, and like I said, reliable. And you want to always keep the end goal in mind. So you are trying to provide an asset that enables decision-making for your business. And of course, that's analytics. So very data intensive, analytics intensive view. So you really want to, why would you do this versus some other things? But the key benefits, and the reasons you're going to get more value out of your data at a lower cost. So by making it reliable, by making it scalable, you can get more value out of it. You can empower business users with that data. You can empower different groups around the organization with that data and the analytics that you get from it. It makes it easier to build more advanced features on top of it with machine learning and other advanced analytics techniques. And really, I think that's kind of the key part, is kind of promoting data culture. Kind of promoting the idea that clean data is critical for the business, and it's critical that you are able to get that data through your analytics pipeline without bottlenecks, so that you can actually make decisions and move your business forward. So, any questions on that? I do want to make this interactive, and I will have some questions for anybody. But I thought at least, give an opportunity to at this point have any kind of discussion that people want if they're not clear about what I'm talking about. Well, all right. Okay, so now the next step of this is actually trying to point out how you might build a data product. And one thing that we've been seeing and have been working with a bit is a tool called DBT. And DBT is a tool that is the T in ELT, while ELT is extract data, load data into a data warehouse, and then transform it. So it's different from the ETL, where kind of ETL requires a lot of transformation before you get it into the data warehouse. But as people have moved to things like Snowflake, Redshift, larger data platforms, of course, IRIS is in that mix as well as a full featured data platform. It became apparent that you could really just focus on the transform part, load the data as it is in whatever raw kind of format, and then transform it. And then so modify your data in that data platform. And that enables, a very kind of smooth ingest, because you just put it in, and then focus on cleaning it up after that. So it just kind of shifts where you do things, but also makes all of that transformation and cleaning up code something that you can organize centrally because it's in one data platform. And we think that model fits IRIS very well, because if you started from IRIS having a lot of transactional data, and then add analytics and use our analytics capability, you're really putting all of that functionality and that data into one consistent platform, and using the power of IRIS and SQL to do the transformation and to really turn that data into usable data and analytics ready data. So with DBT, it's open source. They do have a company. And I want to put out front that our support within IRIS for DBT is experimental at this point. We really have a community adapter that one of the attendees on this call has put a lot of effort into, Dimitri, and he can talk about this a little bit, give him a chance to chat about it later. But we don't have any relationship with the company or DBT, just to be clear, and we don't have full support for this kind of usage, and we're working towards that internally at InterSystems. We are definitely moving in that direction. We'll have a fully supported DBT adapter. But the community supported adapter works great, and it's something that you can use now, and we'd love for people to use it. So anyways, DBT, as I mentioned, open source tool, and you define your models using SQL. So it's a very SQL forward, SQL centric, but also Python developed tool. And it really enables kind of version controlling, testing, and documenting your code all in one system that makes it very easy to build these kinds of data products. So another thing that it does is it manages the dependencies between the data models and those transformations, makes it easy to maintain and evolve your data infrastructure over time. So that's very important, as everybody knows in business. And a really great thing about it is the DBT community is very large, and there are a lot of people doing very many different interesting things with DBT. So that makes it a pleasure to work with and very fun. So the main concepts in DBT are models, which are SQL select statements that, of course, within those select statements, you can put a lot of transformation code. Takes a table as input, and it transforms it and outputs a result table. There's also packages, which is a collection of SQL functions, and goes within like a DBT project. So projects are managed consistently and on disk and within like Git repository. It's very friendly with working with Git. And you have, of course, a source table that you start with. So every kind of DBT project starts with sources and then has a series of models that transform the data successively, starting from kind of raw, then to kind of analytics ready data at the end. And you have an exposure, so you represent excuse me. Oh, I thought someone said something. So then you have you have to then expose that DBT product or whatever the output is for downstream use. So this kind of gives a who's it for, So of course I talked about the export, load, and transform. That export part, the EL part, is kind of with data engineers, and the T is for analytics engineers. So it's code based. You have to be a coder to be using DBT, and for those that are really working with analytics. And then after that DBT and the ELT is done, then a data analyst can actually work with that data, maybe build dashboards and develop insights and reports off of that. So really cool thing about DBT is that it's every project that you have, like from the get-go, it's documented. So it just nicely gives you a web interface to click through and show all the different steps and all of the code that you have. This is really great for anybody within the organization to understand what's going on. They can see the different steps. They can see all the all the things that are going on in your project, and that really helps with the cross-company aspects of it. There's different packages, so you can kind of dig in and see each little stage, each kind of table, all the columns that are there, and you can also see the code for each step of the transformation. Another thing that's great about DBT is that it really keeps track of your data lineage, as you have all those input tables and multiple steps of transforming different tables. It can get complicated. So DBT gives you a nice little interface to see which steps depend on which others, and you can click around and see things that way. There's also this concept of an incremental model. So as I mentioned, those models are select statements. You can imagine if you have a very large table, those could get very difficult to, or very, very time consuming. So there's a concept of keeping track of the of what data was already there, and using kind of a unique key to just make sure you only get the new rows. And so DBT supports that with a very simple kind of syntax. Another great thing about DBT is that as you're building a data product, it has a lot of testing built in and a testing framework, so that every time you make a change, you can run your tests, and it actually checks for things like, do you have any nulls? There's no way to have like nulls in your primary key columns with DBT. You're going to know about it right away because the tests will run, they'll fail, and you'll have to fix it somewhere along the line. So that is a really nice feature. So, and this just kind of recaps all those things about DBT: tests, parallel execution. It kind of manages when you're running all of those steps. It keeps track of the dependencies, knows what needs to run first, and what order. Keeps everything, it logs everything, so you can see where you went wrong or what's going on, and it has templating. So we'll look at some of the code where you are writing SQL, but you can put variables in it. You can have loops, so you can really code with it. So it makes your SQL code very maintainable and very powerful, very expressive. And if you didn't think about it so far, all of these features really give you just a lot of flexibility. So these are some reasons why you might, and when and where you might want to use DBT. If you can use version control, you have to be using Git. If you want automatic documentation and that lineage, that's a really good feature from it. Yeah, testing and data quality. If you have a lot of data, big data gets difficult to work with if you're not really managing the dependencies and the code around it. And the developer, if they really know SQL and select, and that's all they know, well, that's probably good enough for their SQL knowledge, and as well any kind of Python knowledge can be useful. If you can collaborate with that Git repository, of course, that's a good thing. And of course, local development. You have to be developing this locally. You can develop it locally or in the cloud. When not to use it. So if your transformations cannot be written in SQL, and you need a lot of other kind of complicated code to do those transformations, might not be the best tool. If the tool is needed to do the whole ELT process, that wouldn't be good, because DBT only does a transformation. If you need all of those pieces, the extraction and the loading, that's maybe not going to be the best use of your time. And if you have to have simultaneous updates and collaborating, that makes it hard. You really need to have this kind of single source of truth in your Git repository, and things have to be managed at least somewhat sequentially that way. And I was going to mention, yeah, so there's that local versus development on the cloud issue. Okay, so what was I gonna show? I'm gonna show a little bit of a demo here and what we did with this to show kind of our data product that we built. It's not much of a data product, but just an example. And let's see, hold on. Am I sharing still?
Nope.
Okay. I'm not sharing?
No.
Oh, okay, sorry. All right.
Yeah.
How's this?
That's it. Mhm.
Okay, so the data we started with, so I'm going to switch over to dbeaver. So we have this retail data, and this is our raw data that we're going to start with. And as you can see, it has a timestamp. You've got this, it's kind of a date time thing as well. An ID, so an ID for each row. You have categories, so you have different categories. This is from Walmart data. It's from a big time series forecasting contest, some extract of the data. Your item either is from a food category or household or other kind of items. Departments, so even within foods, there might be multiple food departments. And then the item ID is pretty much just a concatenation of the department and something about the actual item. You have a state in the US, a United States state, a store, where its store was sold in, and then you have the actual kind of data, units sold, and the price which they're sold from. Now, what we're going to do with this data is then transform it. Oh boy, we're coming right up on time. I didn't realize how long this was going to take. So sorry. So I'll quickly just go into the DBT part. So this is the data that we're going to take. It's kind of long table of data that we're going to transform into a star schema. So more analytics ready, extracting out the dimensions and the measures and having a fact table. And so that's what we do with DBT. And we can show that. Let's see. Okay. And this is what that kind of web interface of DBT looks like. You can see on the right, you have the file that you start with, showing all those columns. And then within the actual DBT models, we had two. This is another model that's within our within that repository. But we call it Starify. So it's like taking that big table and turning it into these individual tables that are more analytics ready. So here you just have a category, kind of making a dimension out of the category, and you can actually see the SQL that we use to create that. So it's a select, and you can see these templating. So that's where you can specify this, where your data comes from, and then DBT actually runs that code and turns it into compiled SQL. And this is the actual SQL that goes to IRIS. The other, and then these things are all very similar. This one might be a little more interesting. Here you can see a select where you're going over that table and joining up all of those the dimensions that we extracted and making one kind of consolidated fact table as the middle of the star schema. So when you're actually running this, so then when you look in the command line, how you actually work with it, you can just do dbt deps as one kind of command, where you can just see how see if you have all the dependencies you need, because you can actually install a bunch of extra packages. And I mentioned you can do dbt test. Anytime you can run this and it'll run all of your tests and see if they pass or fail. And then when you actually want to run it and perform all these transformations and create this, create your end result, you just do dbt run. And it goes through and runs whatever needs to run and creates tables. And those tables then just show up in IRIS. You'll see over here. We put all of these in the star schema. And then all of those tables are perfectly created. And you can see here, that you just have IDs into all of those dimension tables. So really nice way to kind of transform your data. So just say that is the big benefit is that you transform it. You can always back it up, just manage it all with code. And that makes it very, very useful. Okay, well, that's what I had to show, and I went way over time. So we can chat about it now. Oh, I did want to ask if anybody had any thoughts about or could share like what they're doing now for ELT or ETL, and if they've thought about incorporating some different analytics tools within their work. That'd be nice to hear from people about that. Guess not. Oh, we have some questions?
No, I guess not.
Okay.
Do we have any more questions?
I would like to add a couple of words. So the main big feature of dbt here is that as soon we have big tables and all the working SQL, but all this SQL are working on a server. We do not transfer any data between your machine and server. It's just only executing SQLs. And well, when you transform one table to another, it's just create one table with a new different structure out of another table, but it's just only SQL which running on a server, and it's working very fast just because of it.
Yep. Absolutely. Very nice. Okay. Sorry I went over. I think
yeah, thank you so much.
Yeah.
Thanks everyone who's staying with us. Like we are a little bit over this. Thanks for your amazing presentation. I just wanted to highlight that it will be recorded, and we unfortunately don't have more time for questions. But if you have questions, please go to our developer community, and we will make sure to answer all the questions and tag Thomas and Benjamin and our other great community members. Dmitry is here as well, usually answering all the questions too. Yeah, and if you have also suggestions for topics for next roundtables, like what you would love to hear from us, like which topic you would love us to cover, also feel free to post that on developer community. And I'm leaving the link to the developer community right now in the chat. And the recording of this roundtable also will be available there on developer community. So
right,
thanks
thank
again,
you.
everyone, for joining. See you there.
Bye. See you, Dmitry. See you, everyone.
See you.